So we are going to go ahead and fill in our notes on deductive reasoning. So find in your notes packet where we start to talk about deductive reasoning, and the definition's already written in for you. So I just want to take a second and have you guys listen while I tell you some key ideas. Deductive reasoning actually uses facts, definitions, properties, and laws of logic to form a logical argument. So the big difference between deductive reasoning and inductive reasoning is that deductive reasoning, we are actually basing our thoughts on facts, as opposed to, if you remember, inductive reasoning, we were just kind of making assumptions based on a pattern. We were making a guess based on patterns we see. Deductive reasoning is based on actual facts. So we're not just thinking what might happen, we're going to know what's going to happen because it's very factual. So if we look at our three different types of deductive reasoning we're going to learn, there's a lot more. We're focusing on three. The first type is the law of detachment. In the law of detachment, it says if the hypothesis is true in a conditional statement, then the conclusion is also true. So in this, you would be told if P, then Q. I'm just going to use symbolic notation. And then someone's going to tell you P happened, which means Q also had to happen. So if we look at this example here, the conditional statement, if Nathan is enrolled at Yorktown, then he will have an ID number. This is our conditional statement. And we could even say here, let's make it a little more generic. If a student is enrolled at Yorktown, then he will have an ID number. Well, we're told, and I'm going to take this word out, we're told Nathan is enrolled at Yorktown. Well, we just had the statement that says if a student's enrolled in Yorktown, he will have an ID number. And now the second statement says Nathan is enrolled at Yorktown. Well, what can we conclude? That he has an ID number. That is the law of detachment for us. Now, the law of syllogism says if we have two conditional statements that are true, if A then B, if B then C, then we actually get to assume A to C. So we're going to go ahead and take out that middle part of B. And that's what the law of syllogism has. So we're going to go ahead and write in your law of syllogism, where we get to say if A then B, if B then C, then the actual conclusion we get to make, our conclusion is going to be if A happens, then we know we're guaranteed that C is going to happen. And we're going to look at an example of this. Let's see. All right, so the third kind would be the law of contrapositive. So the law of contrapositive says if A then B is true. So we've got to start with something true, just like law of detachment starts with a conditional statement. But now we're going to be told that if not B. So we're going to actually be told that the hypothesis, or the conclusion did not happen, which also means that the hypothesis could not have happened. So this is going to be our conclusion here. So if this is an example of this, if YHS wins the football game, then they will win the division. So this is our A-B statement. Then we are told YHS did not win the division. So we're allowed to conclude that YHS did not win the football game. So if we take a look at some of the examples we have, all right, so if we go ahead and look at these examples we have at the bottom of our page, Jeff knows that if he does not do his chores in the morning, he will not be allowed to play video games later the same day. Jeff does not play video games on Saturday afternoon. So Jeff did not do his chores. So we have this original statement here. Jeff knows he did not do his chores. Then he will not be allowed to play video games. So that's our original statement. Jeff does not play video games. So now we know that the conclusion is actually true. So if we call this our conditional statement, does not do chores, does not play video games. So no chores means no video games. Well, the next statement tells us Jeff does not play video games. So that tells us the conclusion is true. But just because the conclusion is true doesn't mean that it's because of the hypothesis. So if you look over our rules, we have a rule that says if we're told the hypothesis is true, we can assume the conclusion. But just because we know the conclusion happened doesn't mean it has to be because of the hypothesis. So this is not a valid argument. And what I like to say here is we know what happens if he doesn't do his chores, but we don't know all the reasons he might not play his video games. He might also not play his video games if he wants to go to a movie instead, or if he doesn't do his homework. We don't know what the reason is for him not playing the video games. So just finding out the conclusion is true is not enough to be able to say that the hypothesis is true. The law of detachment does not work the other way around. So let's read this one. Katie knows that driver's education students in her school are sophomores. So driver's ed means a sophomore. Brandon takes driver's education. Therefore, Brandon is a sophomore. So Katie knows driver's education students in her school are sophomores. Brandon takes driver's education. So in this one, we know that Brandon is in driver's education. So we know hypothesis is true, which in our law of detachment, by law of detachment, means that this is a valid argument. All right, so then let's look at this last one. If the road conditions are icy, then they are hazardous. The road conditions are hazardous. So pay close attention to the first one and the third one. Roads are icy, then they are hazardous. Icy roads, hazardous. But then it says the road conditions are hazardous. So our second statement is that the conclusion is true. So the second statement says Q is true. Well, remember what we talked about up here. Just because Q is true does not mean it's because of the hypothesis. So this is actually another invalid argument. And what I always like to think about this, what else could make the roads hazardous? Does it have to be icy to be hazardous? No. So you could think there is an accident, there's a spill, there's rain, there's potholes. There's a ton of things that could make the roads hazardous that doesn't include icy. But once you know the roads are icy, they have to be hazardous. So this is invalid. Just knowing the conclusion is true is not enough to be sure that the hypothesis also has to be true. So let's just go ahead and take a second to look at two other examples. to just make sure we understand law of detachment. So if you look at the next examples, it says if two angles are right angles, then they are congruent. Remember, congruent just means equal. So this is one more example of a conditional, and I just want to make sure we all see where we are in our notes right now. What can we conclude, if anything, from the following statements? So hopefully you guys can find this spot. So if we know two angles are right angles, then they have to be congruent, and then you are told this statement. So I want to keep saying this is kind of the given statement that angle A and angle C are right angles. So our conclusion by law of detachment is that angles A and C are congruent. We are saying, based on the fact I knew the hypothesis was true, that now the conclusion has to be true. And remember, that does not work the other way around. And think about it. If I said if two angles are right angles, then they are congruent, and then I said two angles are congruent. Well, just because two angles are congruent doesn't mean they have to be right angles. So knowing the conclusion alone is not enough. So then if we look at this next example, and I'm just trying to make sure I'm going with your packet, if Larry is sick, then he will be absent from school. If Larry is absent, then he will miss his math test. So again, right here, we have, this is the law of syllogism. So we have a P to Q statement, and then notice the repeat statement. Absent, absent. So if Larry is sick, he will be absent. If Larry is absent, then he will miss his math test. So this is by law of syllogism, and let me just say Q to R, we can call it whatever. Then what we would say here is, since Larry is sick, then he will miss his math test. If Larry is sick, he will miss the math test. Now, this is because he will be absent, but we don't even need to write that part. So this is our law of syllogism here. So now I would like for you guys to try to finish filling in this box with the conclusions you can make based on the statements, and this will give us a great place to pick up and discuss in class.